Hi, everyone. Okay, right now I'd like to show you how the XL500 laser, that's this here, and I'd like to show you how it works, or how to operate it, I guess. So the entire laser unit is inside of here. It's actually what's called an optically pumped titanium sapphire laser. It has a pump laser, a 15-watt pump laser here that powers a second laser based on lasing in titanium doped sapphire crystal. This type of laser can be mode locked, which means it can be made to produce a stream of very short pulses. Okay. And when this is operating, it produces a stream of pulses, uh, 5 million pulses per second, and each pulse is only 50 femtoseconds long. The average power is about 2 watts at the exit of the laser, and that corresponds to a power within each short pulse that's extremely high. I'll let you work it out. Okay. Right now, the laser is on, but it's safe because the shutter at the end here is closed, so no laser radiation is being emitted. And so that'll be the state of the laser when you come in. And I want to show you how to open the shutter. Before you open the shutter, you need to do a couple things though. First, you need to put on laser safety glasses. These will be the blue or green glasses in my lab. Um, okay. And the second thing is you need to know where the beam from the laser is going to go when you open the shutter. Right now, when you open the shutter, the beam will come out and it will go to this power meter and be blocked. So it's safe. And when you operate your experiment, the beam should also be safe too, of course. Um, but just take a look before you start out. Now, to open the shutter, we just press the shutter open button on this control unit. Very elaborate, actually. And it's just this. I'll press it and hold it down for about 10 seconds. There's a beep to let you know it's coming. And there it is. The shutter is now open. Here, 1 second. Let's take a look at the laser beam. Okay, now the laser is operating. How can we tell? Of course, you can't see the laser beam if you have the glasses on. I'm not sure if you can see it in the video camera, probably not. But you can see it using this laser viewing card. When the laser beam hits it, the screen will fluoresce. And so if I put this into the path of the beam, you should see it light up. Okay? And hopefully you can see that on the video camera. I'm not sure if you can, but you'll see it with your eyes. There's another way you can tell. Right now, the laser beam is going to the power meter, and the power meter is reading a power here. Uh, the power meter is currently on the 3-watt scale. The needle is at this point, which corresponds to about 1.8 watts. So the average power is 1.8 watts. And then there's something else. A small part of the beam is being split off for diagnostic. Um, there are 2 units here. One is a spectrometer, which we're not using now because we're going to use a different spectrometer. But the other is in our experiment, but the other is a unit called an autocorrelator, a real-time autocorrelator. And it's showing us the pulse shape, which it determines in an optical measurement that I won't go through right now. Okay? The entire width of the screen corresponds to about 200 femtoseconds. So it's showing you a pulse that's, on the order of, well, you can see it here, maybe 100 femtoseconds wide. I'm going to make an adjustment to the laser system now that should change the pulse shape. Oops, I have to just adjust something. Hang on. Okay, we're actually viewing an oscilloscope screen and I just had to adjust the oscilloscope. In any event, um, There, now the pulse shape looks quite good, okay? And so the pulse width is about 50 femtoseconds now, which is the minimum pulse length for this system. All right, well, that's the diagnostics. If I wanted to shut the laser off at this point, I would just press the laser shutter button again. And then the laser is shut off. Okay,